Welcome, this is lesson 6.3, Compound Inequalities Special Cases. So what we're going to look at today is the 4 special cases that come up with absolute value inequalities. So if you look at our first case here, we have x is greater than -5 or x is less than 2. So if x is greater than -5, it would be an open circle and it would go to the right. If x is less than 2, that would be an open circle, and it would go to the left. But in OR inequality, only one of them has to be true. Because this OR inequality covers the entire number line, because it does overlap, but it's still true if just one is true, the final answer, so if an OR inequality faces each other, the final answer is all real numbers. So that's our first special case. So when an OR inequality overlaps, the final answer is all real numbers. Now, our next case has to do with the end inequality. So we have x is less than -1 and x is greater than 7. So we're going to graph this. We have our 0, we have our -1, we have our 7. X is less than or equal to -1 is closed and to the left. X is greater than 7 is open and to the right. Now what should happen in an end inequality is they should overlap each other. And where they overlap is your answer. Because these do not overlap in any space, an end inequality that does not overlap gives you a solution of actually no solution. Because none of the terms will work for both sets. So an end inequality that goes opposite each other would be no solution. Now our third case is back to the OR, but instead of covering the whole number line, these will overlap and you'll see part of the number line covered. So what we have is x is less than 3. Which is an open circle, and it goes to the left. And we have x is less than or equal to 6. So you can see from the graph, both line segments go in the same direction. Because an OR statement only needs one to be true, we wouldn't have to say both of these because it's all covered under x is greater than or equal to 6. Because it doesn't have to overlap for an OR statement to be true. Just one needs to be true. So x is less than or equal to 6. Okay. So if an OR inequality goes in the same direction, you start with the furthest one, and that's your final answer. And our last special case with compound inequalities is x is greater than -8 and x is greater than or equal to 0. So x is greater than -8 and greater than or equal to 0. If x is greater than 8, it would look like this. If x is greater than or equal to 0, it would look like this. Now in an AND inequality, they must overlap. Well, these two inequalities overlap in this section here. So it is that overlap that is our final answer. So our final answer here would just be x is greater than or equal to 0. So in our special cases, again, there are special cases. They don't come up that often, but they do. A special case does basically takes what's there and does what it's not supposed to do. An AND inequality should come together, and OR inequality should go apart. If that does not happen, you have one of these special cases.